Wait, I'm trying to figure out this for a while. I'm so sorry. Because it seems that you all cannot this comment, isn't it? So I'm going to make this commentable uh, so that you all can ask all sorts of questions. To be honest, I'm not very good with the YouTube things. Let me check for a while. So sorry, yeah. I'm so sorry. uh, I how to enable these chat things? Because you see, I don't know how to make this chattable. Sorry, I really bad at this. Sorry, give me like 1 more minute. You see, cannot click on that. So I also not sure why. Uh, well, anyway, if you all have any questions, you can always question me on ask me on privately or whatsoever, maybe in the groups. So I will try my best to respond as much as I can. So without any hesitation, let's begin, shall we? Because time waits for no man. Okay, so we are going to continue from where we stopped yesterday. So yesterday we stopped at question number 30. So we are going to continue with question 31, shall we? Okay, so this one no problem. Okay, 31. A well-characterized compound contains potassium, sulfur, and oxygen. The assay values are potassium 49.41%, sulfur 20.261%. Determine empirical formula for this compound. Now you can see in here, they only give you potassium and sulfur, but yet the question says that it contains potassium, sulfur, and oxygen. So how are you going to determine the percentage of oxygen? So all you have to do is just using the 100% minus off 49.410 and 20.261, so that you get your percentage of oxygen is equals to 30.329. Okay, so then you use the empirical formula methods to uh, calculate, where you divide it by the molecular mass. Now, whenever you are trying to find the relative atomic mass, make sure that you find the value from the periodic tables. Don't memorize any of these values on your own, because some of you, your levels, let's say SPM levels, SPM levels, sometimes they use different, they only use two significant figure. Okay, for example, magnesium is 24, but in STPM, magnesium is 24.3. So some of you have the habitual to memorize this relative atomic mass. So make sure that you are not going to memorize this. Okay, so always refer to the periodic table. Now, after you calculate the mole for each of them, okay, so you get your mole of potassium 1.26, mole of sulfur 0.633, and mole of oxygen 1.90, and then you divide by the smallest mole, which is the sulfur, and you get your ratio of the potassium to sulfur is 2 to 1 to 3. So this will make your empirical formula for this is K2SO3. So the answer is A. So that is for 31. And then 32, a washing powder contains sodium hydrogen carbonate and HCO3 as one of the ingredients. In a titration, a solution containing 1.00 gram of this washing powder requires 7.15 centimeter cube of 0.100 sulfuric acid to complete reactions. The sodium hydrogen carbonate is the only ingredient that reacts with the acid. What is the percentage of the mass of sodium hydrogen in the washing powder? So in here, you need to write the balance equation for the reactions when you react with the sulfuric acid. So in here, the general equations will be 2NaHCO3, okay, The general equation will be 2 NaHCO3. Okay, 2 NaHCO3 plus H2SO4 give NaSO4 plus 2H2O plus 2CO2. So you need to know how to balance the equations. So you first calculate the mole of sulfuric acid. So you get you use MV over 1000, 0.100 times 7.15 over 1000, you get 7.15 times 10 power of -4. Now because the stoichiometrically in here is 2 to 1, as you can see here, the ratio of the sodium hydrogen carbonate to sulfuric acid is 2 to 1. So the mole of the sodium hydrogen carbonate will be multiplied by 2. So you get 1.43 times 10 power -3. So therefore, you get your mass of the sodium hydrogen carbonate. You multiply by the relative atomic molecular mass of the NaHCO3, which is this one. So at the end, you get your mass is equals to 0.12 gram. Therefore, the percentage is 0.12 divided by total mass is 1.00 as mentioned by the question, okay, times 100%, so you get 12% in here. So the answer will be C. So in here, you must be very good in the mole concept, hence determining the percentage by mass of the sodium hydrogen carbonate inside the powder, okay? Okay, so with that, that is how you solve for question 32. As for question number 33, a sample of element X is analyzed using mass spectrometry. The mass spectrum obtained is shown below. So that is the mass spectrum that you have. Okay, so you use the same general formula of how to calculate the relative atomic mass. So you use the abundance multiplied by the total abundance multiplied by the isotopic mass for each of them. Okay, so you get your general formula for this one are RAM of X is 3 times 112 plus 56 times 114 plus 41 times 115 over 3 plus 56 plus 41. So at the end of the day, you get your final answer as 114.4. So which will make your answer is equals to D. Okay, so these are very straightforward questions. I hope that you can understand on how to solve. Okay, then we goes for 34. In this question, it should be assumed that NH4,2CO3H2O dissolve in water without causing an increase in volume. So which mass of the NH4,2CO3H2O ammonium carbonate hydrated should be added to 800 centimeter cube of water to form a 0.100 solution of ammonium ions. So you have to understand in here, 1 mole of this salt contain how many moles of the ammonia. So you have to know that because of the NH4 you will expect that 1 mole of this salt will dissociate 2 mole of the ammonium ion. So you use MV over 1000 to get the mole because you want to find out what is the mass that you should use. So mole of the ammonium ion, you use MV over 1000, so you get 0.100 times 800 over 1000, you get 0.08 mole. So stoichiometrically, 2 ammonium ion is to 1 mole of the salt that you want to use in here. Therefore, you have to divide by 2. Okay, so in this case, if you are not very sure whether you should multiply or divide, always use the ratio method. You know by yourself that the ratio of NH4 to the salt NH4 to CO3 is 2 to 1, isn't it? Okay, so if you have 0.08, let's say, so what is your X in here? Always use these ratio methods to determine your mole. Sometimes some students who claim to be very good in mathematics, you might also make these silly mistakes. So it is always more secure if you use the ratio method to find out the mole. Okay, so you get your mole of the salt used is 0.04 mole, and then you multiply by the relative molecular mass of the salt in here. So at the end, you get your answer as 4.56 grams. So in here, which makes your answer is A. Okay. And last but not least, question number 35. Compound J burn in excess oxygen to give carbon dioxide and water only. When the 3.00 gram of compound J is burned in excess oxygen, 4.40 gram of carbon dioxide and 1.80 gram of water is formed. What is the empirical formula of J? Now, in here, they didn't tell you J contain what, but the answer itself in here, you can see either they contains they must contain C and H, and some of them may contain O. So what is your best answer in here? So first of all, you need to find out what is the mass of carbon and mass of the hydrogens inside the sample by relating them with the mass of the carbon dioxide and water given. Now, given to you general equations for the reactions, CaHYO2, this O might be optional, but looking at the way of how it ends up, there will be oxygen inside there. So how to find out later, I'll show you. Okay, so stoichiometrically, if one CxHyOZ give one CO2 and Y over 2 H2O, so in terms of mass, okay, it is the same. You see, when you say one carbon is to one carbon dioxide, isn't it? In terms of the mole ratio, we said that 1 mole of carbon is 12 grams, correct? And then at the same time, 1 mole of carbon dioxide is 44 grams, isn't it? This is 12 and 44 is the RMM for carbon and carbon dioxide. So still the same, you use the ratio methods to get the mass of the carbon and carbon dioxide. So they already give to you, so 4.40, isn't it? So at the end, you can find out that your mass of the carbon is 1.2 gram. Okay, water also the same. So in here, we say is that 2H give 1 H2O. So in here, you use 2 times 1 gram, okay, is to 1 times 18 gram. Okay, so if you want to find out what is the amount of the hydrogen, so you divide with the mass of the water. So at the end, you can find your gram is equals to 0.2 gram. Okay, so you see in here, you have the mass carbon 1.2, hydrogen 0.2. So the remaining 3.0 gram is what? The remaining of the that makes the 3.0 gram is oxygen. Okay, so therefore you get your mass of oxygen 0.16. So how to calculate empirical formula? So 1.2 divided by 12, 0.2 divided by 1, and 1.6 divided by 16. So you get your mole ratio 0.1, 0.2, and 1. 0.1. So at the end, what is your empirical formula? Your empirical formula will be donkey D. So this is how you are going to calculate for such question where you are going to use the mass of the carbon to carbon dioxide and hydrogen to water. Okay, so this is a very typical STPM style questions. So you must know how to calculate it. Okay. So I believe with that, that is all for the objective questions that we would like to discuss in here. Okay, so without hesitation, let's move on to how to answer structure and essay. Now, I believe that the answer is already behind the books if you already purchased my books, okay? But in our lesson today, I'm more to showing you on how to answer. I mean, what directions will lead to the answers that you all should know whenever you are studying for STPM chemistry. Okay, so with annexation, making use of these examples, I shall shows you on how you are going to understand. Okay, so let's have a look at our structure questions, starting from question number 1. The diagram below shows the deflection of the subparticles from different sources that are passed through an electromagnetic field. Actually, it's a electrical field, where you have a positive magnitude and you have a negative magnitude. Okay, so you must know by yourself what is the subparticles that goes through the positive terminal. So the subparticles that go through the positive terminal is definitely electron. Okay, while the subparticles that is going to the negative terminal is definitely proton, where the subparticles that does not deflect is neutron. This one is something that you should generally know on your own. Okay, so therefore when the question asks name, okay, be careful with the terms that the question already highlight. They said name, so you must name them. So name the subparticles of 10P. So the 10P in here, which is P which is P. Okay, so P in here is neutron. So you must try your best to spell correctly neutron, N-E-U-T-R-O-N. Okay, so you cannot put the symbol N, cannot, because the question already said that you must name them. Okay. Okay, B. Identify subparticles 11Q and explain the angle of deflection of Q beta compared to alpha. Okay, so in this case, how are you going to compare the angle of deflection between beta and alpha? So you can imagine as something like this. Let's say you are now, let's say you are here, okay, this is you for example. you are trying to throw a piece of paper and a stone. Okay, stone has greater mass, isn't it? Paper has no mass, it's light, isn't it? Okay. So when you try to throw, what will happen? So you see here, the stone can uh, throw further away, isn't it? But in terms of paper, so when you throw the paper will just fly over here only. Okay. So what does it mean in here? It means that for distance, okay, for distance, greater mass, okay, further the distance. Okay, then you imagine that if now we want to pass through to a line in here. Okay, let's say this is the normal line. I'm going to use different colors so that, okay. So imagine that if this is the normal line, okay. Sorry, my normal line is not straight enough. Okay, if this is the normal line, you will find out that the angle in here is smaller. Okay, while the angle in here is greater. Okay, so at the same time, when you have further distance, the angle of deflection will be smaller compared to this one. So that is how you are going to compare between the angle of beta and alpha. So imagine that. So this is the electron, while this is the proton. Okay. Okay. So as a result, you can find out that Q is proton, of course. Okay. So in here you must explain. The question asks you to explain the angle. So you must, of course, first explain which one give a greater angle. Either you say beta has a smaller angle or alpha has a greater angle, okay, compared to beta. So up to you on how you want to describe your words. Okay, why? Because particles is heavier. Okay, or you can also answer it has a greater, actually a more accurate answer you should answer as it has greater mass over charge ratio not E, sorry. Mass over charge ratio. Okay, so either you say Q is heavier or you have a greater mass over charge ratio. So that will be the 1 marks inside here. Okay. Okay, so with that, that is for question number 1A and 1B. Then we have a look at 1C. In the diagram, draw the path of another particles 1r that is passed through the same electrical field and explain the distance of deflection compared to the subparticles Q1. So I'm going to scroll back to the previous one. Okay, so the question already said inside the diagram, so you must draw. So if this is the 2,1, and then you must look, the substance in here is 2,1R plus. That means when you have plus, okay, you have a positive charge subparticles, it must deflect to which, this one, you must deflect to the negative plate. So you draw inside the diagram in here. The question already said you must draw inside the diagram. Okay, so you draw this. And then write R21 like this. Okay. And then you have to explain why is it that you have R is a greater distance. So why R has a greater distance? So since R has a higher mass over charge ratio, therefore it deflects further. Okay, so that is how you are going to explain the answer for this one. Okay, so I've explained on about what are the factors that will determine the distance of deflection. So hopefully you'll be able to understand better. Okay, so with that, that is for question number 1. So let's have a look at question number 2, shall we? Table below shows the table of the informations of number of proton, neutron, and electrons from a few particles. So questions A sounds like this. Whenever you are given the tables like this, if you have the leisure time, you may fill up the table, but you might want to consider the time that you have. Okay, but in this case, since we are studying, okay, we are learning, so let's together fill in the tables, try our best to fill in everything inside the table. So in here, when you have neutron 21, electron 19, and this is 19 potassium, so the this one also 19 lah. Okay, then 19 potassium is also 19, 22, number of electron is also 19. Okay, so P1X, so P is 31, 15 when you have X minus. So because you don't know what is X minus, so you put a question mark in here first. Okay, and finally 32AX is 70. So later the questions will lead to us here. Okay, so here are the questions. Potassium 40, 41 are isotopes of potassium 39, where the percentage of abundance for K39, K40, and K41 are 93.2, 0.20, and 6.60. Now, you must be very sensitive with the decimal place inside here. So most of them contain 2 decimal place, if you notice. They contain 2 decimal place. So what does it indicate? It indicates that your final answer later must also have 2 decimal places. Okay? So potassium 40 is used extensively together with argon, also known as potassium argon dating, in the geological to determine the age of the rock, while potassium 41 is unstable isotope. So 1, define isotope. So you must exactly know on how to define isotope. Isotope must have this following keyword. Here are the keyword. The first keyword must be atoms. Okay, you cannot say particles. You cannot say substance. You must insist the word atoms. Atoms with the same proton number, or if you say number of proton also can. Okay, but with different nucleon number. Nucleon number, you can also say number of neutron. Okay, you can also say as number of neutron. Okay, so either way, they are the same. Okay, so this is how you are going to indicate in here. Okay, so based on the information, so this is how you define isotopes. Okay, number 2, based on the information, calculate the relative atomic mass of potassium. So you use the same formula. So atomic mass of the potassium is 39 times 93.2 plus 40 times 0.20 plus 41 times 6.60. Remember this technique, substitute as exactly given to you in the question. Question give you 39.2. You must substitute 39.2. Question give you 0.20. Question give you 0.20 and 6.60. You must substitute as 0.20 and 6.60. We will penalize you if you just put 0.2 wrong. Okay, if you just put 6.6 also wrong, we will not give you any marks for that. You must substitute as exactly given to you in the questions. Okay, and then finally, over 93.2 plus 0.2 plus 6.6. Now, I usually don't recommend students to straight away put 100. I don't recommend. You should show on how you get the 100. Okay, so use this method, 93.2 plus 0.20 plus 6.60. And then sometimes it may not be 100%. Okay, so you have to be aware of this. So the key in the substitution in here is substitute as exactly given to you in the questions. Okay. Okay, so press your calculator. So you get your answer as 39.13 in 2 decimal place. So 2 decimal place. In here, you have to look at most of the values inside the questions. The questions in here have 2 decimal places, so your answer must also be 2 decimal places. Okay. Okay, so that is for question number 2. Okay, so with that annexation, then we goes to question number 3. So other than potassium argon dating, another radioactive isotope is also well known for determining the age of fossil. Name the radioactive isotope methods. So mentioned. So in here, you must know by yourself that this is the applications. So there is only one thing that can determine the age of fossil, which is carbon-14. Okay. Okay, and then number 4, explain why potassium-41 is unstable. The question, the statement this says that potassium-41 is unstable isotope, isn't it? So you have to explain why. So you cannot say why potassium-41 is unstable because it is not stable. So it is like answering to the question back. It's not answering to the question back. You are repeating the question itself. So it is not going to help. Okay. So why is it potassium-41 is unstable? So here are the way of how you should answer. Either you answer as saying because it has a short half-life, or because it is radioactive, or because it disintegrates easily. That's another answer, which is disintegrate easily. Okay, so that is how you should answer why is it potassium-41 is unstable. Okay. Okay, so that is for number 1A. For B, particles Px minus is isoelectronic with potassium-39. Okay, the keyword is isoelectronic. So what is isoelectronic? So isoelectronic means same electron. Okay, so explain what do you understand by the terms isoelectronic and determine the charge carries by Px. Okay, so allow me to scroll back to the previous page. So isoelectronic with 39.8, so which is 18. So in here, your number of electron is also 18. Okay, so if proton is 15, so electron is 18, so X must be 3 minus. That means you accepted 3 electrons in here. Okay. Okay, so back to answer. So isoelectronics are particles with the same number of electrons. Yes, at this time you don't have to say atoms. You can say particles because particles can be atom, can be molecule, can be ions. Okay, so you can say particles with the same number of electrons. Okay, so what is the charge carries by P3x? Charge is P of P is P3 minus. Okay. Okay, so that is how you are going to answer for B. And then last but not least for C, 31, 15px and 32ax are isotonic particles. Okay, isotonic is an old term. In the current STPM syllabus, maybe you won't hear it anymore. But actually isotonic means same number of neutron. Okay, isotonic means same number of neutron actually. Okay, so based on this information, deduce the number of proton and neutrons for particles X. So allow me to scroll back. So when they said isotonic, so you also have 16 in here. Okay, you must be very good with your mathematics. If neutron is 16, then this is 32. Okay, so your number of proton is 16 also. Okay, so X in here is minus, so that will increase back. So that is why for the particles X, number of neutron is 16, proton is also 16 in here. Okay. Okay, so that is all on how you should answer for question number 2. Okay, so any questions you can always ask me, private message me later. Okay, so that is how you should answer for question number 2. Okay, immediately let's move on to question number 3, shall we? In a mass spectrometer, some hydrogen chloride molecule will split into atoms. The mass spectrum of the HCl is given below. Chlorine has 2 isotopes. The hydrogen involved here is the isotope is 11H only. So given to you, this is the mass spectrum. So they will ask you, A, but what particles is responsible for the peak at mass overcharge 36, 37, and 38? Now the question already says you are containing HCl. Okay, HCl. And HCl contains 2 isotopes, while hydrogen is only 1. Okay, so what makes these peaks inside here? So you should know by yourself that this is 36. Okay, this is 37, and this is 38. And you should know by yourself lah, if this is 35, that means this is definitely chlorine 35. Okay, then another one is chlorine 37 lah. You should know by yourself lah. Okay, and then as for 36, it's made of what? 36 is definitely made of HCl 35, and 38 is made of HCl 37. Okay, and don't forget, because we are now discussing mass spectrum, all mass spectrum can only detect positively charged subparticles. So all your fragment must contain a positive charge in here. Okay, so always bear in mind. Okay, they must always carry a positive. Okay, so very clearly, what is 36, 37, 38? 36 is HCl 35 plus, 37 is 37Cl plus, and 38 is HCl 37 plus. Okay. B. Using the relative height of the peak to determine the proportion of the two isotopes, explain how do you obtain your answer in here. Okay, so what is the ratio? What is the proportion? What is the ratio of this one? So if you use your measure, if you use your ruler, you look carefully inside here. This is obviously 30. Okay. And then you use your ruler, you can see that this is obviously 10, isn't it? Okay, as for this one, if you use your ruler, obviously this will be 90. Okay, if you use your ruler, obviously this will also obviously be 30 lah, isn't it? So no matter you use Cl or you use HCl, the ratio is obviously 90 to 30 for HCl or 30 to 10 for Cl. Okay, so in here, the peak ratio of Cl plus is M over E 37, 537 is 30 to 10, hence 3 to 1. Or you say is that HCl ratio of 36 to 38 is 90 to 30, hence 3 to 1. Okay, so that is how you explain the ratio in between Cl35 to Cl37. Okay, then last but not least, use your answer in B to explain why the relative atomic mass. So in here, you have to explain why the relative atomic mass of the chlorine is 35.5. Okay, so you must explain why is it like that. So how are you going to answer? So you say that atomic mass of chlorine is calculated using the average of the chlorine isotopes multiplied by the abundance in here. Okay, so then you show using the formula. How do you calculate? So 35 times 3 plus 37 times 1 over 3 plus 1, or you can use 30 or you can use 90, up 30 and 10, so up to you. No matter which one you write, you should be the same. Okay, so now you are trying to explain. The question already said explain, so how you calculate to get 35.5. Okay, so you must explain saying that it is calculated based on the average of chlorine isotope multiplied by the relative abundance. Okay, so with that, that is how you answer for question number 3. With that relaxation, let's move to question number 4, shall we? Question number 4 sounds like this. When 6.20 gram of chromium is burned with 3.74 gram of oxygen, chromium trioxide is formed. A. Write a balance equation for the action of heating chromium with oxygen. Now, whenever you have this calculation type of the question, you must always be very sensitive with the significant figure used in the question. So in here, the significant figure in here is obviously 3 significant figure. Okay. So here also 3 significant figure. So later when you answer for the questions, especially for calculation, make sure that all of them has 3 significant figure. Okay. Okay, so how to write the balance equation for the actions between chromium and oxygen? So your answer will be 4Cr plus 3O2 give 2ClO3. Is the state of matter important in here or not? Unless they were given, you say that chromium solid, oxygen gas is from chromium trioxide. So If not, then state of matter is usually not important. So you don't put also, never mind. It should be okay. Okay, so that is how you answer for question number A. And then B, and this you have to be careful with this type of questions. This type of question, if your equations, if your equation balance wrongly, then your B and C answer will definitely be wrong. Okay, so you have to be very careful whenever you answer for such questions. Okay, so B, what is the mass of chromium trioxide that will be produced? So you have to calculate for both chromium and oxygen. So mole of chromium is 6.20 divided by 52.0. You have to check the relative atomic mass of the chromium in the periodic tables that is given to you. And then since for chromium to the ratio of the chromium to chromium oxide is 4 to 2. So therefore the mole of the chromium oxide is 0.9596. Okay. Then mass of the chromium trioxide will be 0.0596 times 2 times 52.0 plus 3 times 16.0. Okay, so you get 9.06 in here. Okay, now how are you going to know that which one is limited, which one is excess? Usually when we burn with oxygen, oxygen will be in excess. Usually oxygen will be in excess. Okay, even though the question did not state. If you don't believe, you can use your calculator to press. Your calculator will show you 3.74 divided by 16. Okay, so times 2 okay, so you get your mole definitely greater than 0.2. So obviously the chromium in here will be in excess. Okay, sorry, chromium in here will be the limitant. Okay. Okay, and then C, what is the mass of oxygen that will be left over at the end of the reaction? Number 3. Okay, so since chromium requires 3 oxygen, so more oxygen is 0.0894. So mass of oxygen reacted 0.0894 multiplied by 2 times 16.0 or 2.686 gram. So mass of oxygen are reacted 3.74 minus 2.86 equals to 0.88 gram. Okay, so in this case, you don't have to look for 3 significant figure because this is a fixed number. So they already give you in here, so you just answer 0.800 accordingly. So here you must also be careful with the significant figure. So if the question use 3 significant figure, the answer must also be 3 significant figure. Okay, so with that, that is how you answer for mathematical questions that involve in question number 4. Then we go to the next question, which is question number 5. Natural occurring selenium exists as a mixture of 6 isotopes with relative abundance as shown in the given tables. So you have different relative isotopic mass, 74, 76, 77, 78, 80, and 82 with the different percentage abundance. And number 1, define relative isotopic mass. Now, relative isotopic mass, all of them are actually based on the carbon-12 scale. So you have to define based on that. So it is defined as the mass of isotope of an element compared to 1/12 of the mass of carbon-12 atoms. So whenever you are trying to define relative mass, no matter isotopic, atomic, or molecular mass, all of them are using carbon-12 as the base scale to define the relative mass for all of them. Okay, then number 2, name the method used to obtain the above data. So how do you actually obtain all this information from? So all these information, as we already learned, so they can be obtained from mass spectrum. Now in here you have to answer as mass spectrum. Mass spectrometer is the instrument used to determine the relative isotopic mass, but what gives you the data? What gives you the data? The substance, the materials that gives you the data is mass spectrum. Okay, so your answer in here must be mass spectrum. Okay. Number 3, deduce the atomic structure of each isotope in selenium. Okay, so whenever the question said atomic structure in terms of what? Atomic structure, you must understand it is in terms of proton, neutron, and also electron. Okay, and since they are isotope, proton, electron are supposed to be the same. So proton is equals to electron. This one you can find from the periodic table. Selenium has 34. Whereas neutron, only then they are different. So how different are they? So nuclear number minus proton number. So you shall have neutron equals to 40, 42, 43, 44, 46, 48 respectively. So lack of any information inside there will not give you the 1 marks in here. Okay. So that is how you're supposedly to answer the atomic structure for each isotope in the selenium. So of course you can build a table based on that, but any way of how you answer are actually the same. So it's up to you on how you want to present your answer in here. You can also use a table to present your answer. It's okay. Okay. Then number 4, calculate the relative atomic mass of iron. So how do you calculate? Of course, you use the ratio methods. So 74 times 0.9, 76 times 9.0. As I always tell you, substitute as exactly given to you in the question. And if you look carefully inside all the data in here, okay, if you look carefully inside all the data inside here, you can clearly see that all of them has one common thing. They all only have 1 decimal places. Okay, all of them only have 1 decimal places. Okay, so if all the values in here only have 1 decimal places, so your answer should also be in 1 decimal places, which is 79.1. So sometimes students can be quite confused when to use significant figure, when to use decimal places. In such case, whenever you are trying to determine the relative mass by the given data, usually you have to be extra careful when it comes to the information inside here. They definitely have something in common in between them, so that you will know that what is the best methods to use. So as for the previous question number 4, so when it comes to calculations that involve mole, calculation that involve mole, only then you look into details on how many significant figure used in every of the questions inside there. So that is how you determine when to use significant figure, when to use decimal places. Okay. Okay. So with that, that is how you answer for question number 5. Then we go to the next question, which is question number 6. 0.17 gram of the group 14 chloride react with water to produce an oxide of XO2 and HCl according to the equation. XCl4 plus 2H2O give XO2 plus 4HCl. The HCl produced was absorbed in 100 centimeter cube of 0.1 sodium hydroxide solution, which is in excess. In the titration, the unreacted sodium hydroxide requires 30.0 centimeter cube hydrochloric acid for complete neutralization. Okay, so now in here you have the unreacted sodium hydroxide. So that means the reacted is based on the HCl inside here. Okay. So A, calculate the amount of mole of hydrochloric acid used in the titration to neutralize the unreacted solution. So in here you use the mole concept. So you use MV over 1000, 0.20 times 30 divided by 1000, you get 0.006 mole. Okay. So in this case, when your answer is a round number, don't have to figure the significant figure, okay? Because this one is a round number. You press your calculator, you get a round number, isn't it? When it comes to a round number, you don't have to consider for the significant figure. In another word, you don't have to purposely write like this, you know. Teacher, you said just now, this one is 2 significant figure, this one is 2 significant figure, so I purposely need to write 0.0060. Do you have to this one? No need. Okay. If it is a round number, then you just give the round number based on the calculator that you press here. Okay. So that is for A, 1 marks in here. Then B, write the equation for the reaction between hydrochloric acid and sodium hydroxide. This is very common. NaOH plus HCl give NaCl plus H2O. Very straightforward. C, calculate the amount of mole in sodium hydroxide neutralized in the titration. So in here, you use the calculations, mole of NaOH 0.1 times 100 over 1000, you get 0.10 mole. So eventually this is the total mole of the NaOH. So the unreacted HCl is 0.06. Then the question D will lead to you like this. Calculate the amount of mole of sodium hydroxide that react with the HCl produced with the question in number 1. Okay. So if you understand the whole questions carefully the HCl that you answer in D is the difference from the HCl that you answer in A. Because HCl in D is based on the equation that is given to you, that is produced in here. Okay, that is produced in here. Okay. Whereas this one, the answer in A, is the unreacted sodium hydroxide, because in here the question already says that sodium hydroxide use is in excess. Okay, so the one that is excess that react with the remaining hydrochloric acid, but this hydrochloric acid is the one that is produced from equation 1. So how are you going to find out? So 0.01 minus 0.006, you get 0.004. Okay, and calculate the amount of mole of HCl4 in the original 0.17 sample. So you have to compare stoichiometrically. For HCl is to 1 HCl4, so mole of HCl is 0.001. And hence calculate the molecular mass of HCl4. You use 0.17 divided by 0.001, you get 170. And finally, calculate the relative atomic mass of the X and suggest its identity. So 170 minus 4 times 35.5, you get 28. So X is silicon. See, so please understand carefully on the style of the questions that is asked in here. It might sound a little bit complicated, but you have to read the question carefully. Then you'll be able to understand slowly one by one on how to solve all these questions. Okay, so with that, that is for question number 6. Then we move on to question number 7. The natural occurring sample of cerium contain only 4 isotopes. Data of the 3 isotopes are shown in the table below. So you have isotope of this one, okay, with the different isotopic mass and the percentage abundance. A, given the relative atomic mass of the cerium is 140.116. So find out the percentage of abundance for the 142 cerium. So you just use total, because it's percentage, so total must be 100%. So it's 100% minus 0.185 plus 0.251 plus 88.450. So you can see inside here, all of the values in here have 3 decimal places. Okay, you can see carefully, all of them has 3 decimal places. Okay, so your final answer should also be in 3 decimal places. Okay, and then number 2, calculate the relative isotopic mass of the cerium in here. So you use the overall one, okay, because you're already given the RAM is 140.116. So 140.116 is equals to the summation of the total isotopic mass inside here, okay, over the percentage of abundance. Okay, so eventually you can get your answer of A as 141.915 in 3 decimal places. 1 marks in here. So you must be very good in calculations for this. Okay. Okay, and last but not least, by referring to the periodic table, deduce the number of proton and neutron for the cerium atom. So you have to refer for the periodic table. Proton is 58, neutron is 82. C, cerium-236 is unstable. Define isotope, as already mentioned just now, atom that have the same number of proton but different number of neutron. And explain why 36 is unstable, because of short half-life and disintegrate quickly. Okay, so more or less the same repeating questions inside here. Okay, so with that, that is all for the structure questions that I've already prepared for you. So I guess that is all for the section B for today. So I'm going to end my YouTube for today. So I guess I'll see you all tomorrow, same time, to discuss more about essay. So make sure that you go home and write the essay question. And tomorrow I shall teach you the technique of how to answer STPM essay questions for chapter 1. Okay, so I guess that's all for YouTube today. See you all next lesson. Bye.